Get started. Hello, campers. Welcome to the Science Camp. Henry the Science Kid. I can't talk. Henry the Science Kid Camp, day 1. All right. Let me just set that down. I'm totally a master guitarist, just by the way. I'm the best at guitar. Okay, you guys, welcome. Got 6 people on here. Woo! All right. So, everybody in the stream, I would appreciate it so much if you were A, to like the stream, and secondly, say hello in the chat. All right, and we're just gonna wait for a couple more people to show up, and then we'll get on with it. Woo! As you can tell, I'm still playing the guitar, obviously. It's just, sitting there. I'm just the best at playing guitar everywhere. All right. Alrighty. So let's get started. So everybody, welcome. And as you can see from the title, it is the 4 examples of a chemical change. By the way, hello and everybody in chat. And if you say anything in the chat box, I'm going to try my best to read it as fast as possible. And if I don't get to it, I have a trusty assistant to help me read it for me. Yes, those are the words. Okay, so to get us started, I am going to talk about a little bit of the science behind 4 examples of chemical changes. So, in chemical changes, you have different ways to show that there are changes, chemical change. Okay, I'm just rambling now. So anyway, the first experiment we're gonna do is a special one. And I would appreciate it if in the chat box you would tell me what kind of chemical change you think it is. So the first one we're going to start off by is I'm just going to, grab some stuff here. Yes. Okay. So for the first one that we're going to do, it is going to be with my trusty stuff. So for this experiment, if you want to grab a pen and paper, and I will, oh gosh, this stinks. Write down all the ingredients that I use so you can copy the experiment and do it at home. And some of them you might need parental assistance. Okay, so the first one that we're going to do. So this, if you cannot see, is purple. Now, it is purple because it is pretty much cabbage juice. In a sense, it is cabbage juice. and it reeks. It does not smell good at all whatsoever. And so pretty much if you want to know how to make it, you take cabbage, put it in a blender with water, and I'd say use about 2 to 3 leaves of cabbage to do it, and put it in with water, blend it up, and then you got to strain it. I used a cheese bag thing to get all of the bits of, cabbage out. And so we have our cabbage juice. So basically what this cabbage juice is a pH indicator. So now, as you can see, I have a couple of different stuff right here that I'm going to use for this experiment. So let's just say that we have a completely random thing. Like, let me just choose one of these. Okay, I'm choosing this one. Okay, so as you can see, this is clear, smells like literally nothing, and we don't know what this is. So I'm going to take my little bit of cabbage juice and I'm going to pour it inside. Ready? Super action-packed moment. Okay, so if you cannot see, as I put it in, it turned a bluish color. Now, this means that it is neutral. Now, I'm pretty sure I said this, but the cabbage juice is a pH indicator. Now, if you don't know what the pH is, yes, Kai, you are correct. It is color change. That is the very first one. Now I'm going to do a couple more things with this wonderful cabbage juice. So the next thing I'm going to do, just gonna collect some more cabbage juice here, because cabbage juice is just a wonderful liquid. Okay, here we go. Now we got more of it. We got more cabbage juice, people. Okay, now we have another random liquid. Now this is the color yellow and smells sour. So now I'm going to put in some of the cabbage juice. Look at that. Changed color. Now it is about a magenta to a hot pink color. Now that means it is very acidic. So pretty much this shows a color change. Yes. Okay. Pretty much saying it is acidic, and if you cannot tell, there's also a way to do a pH indicator, and it is with litmus paper, but you can do it easily, well, more simply with cabbage juice. I'm just going to start calling it cabbage juice from now on. Okay, so I'm going to collect a bit more of our wonderful cabbage juice here. Oh, I collected a little too much. All right. Now I have another random thing. Now, we also don't know what this is. It is just some random stuff. So, and we don't know what it is. So I'm going to pour in some of the cabbage juice. Dun, dun, dun. Now, this was yellow. Now it kind of looks like pee. Just a little bit. And it kind of smells like the pool. Now, does anybody have any guesses on what this is? Anybody? It's just, and so as you can see, it really didn't turn blue or a reddish color, which is what the litmus paper does, which shows the pH. And this really didn't change color. Now, I am going to tell you what this is now. This is bleach. Now, bleach is a very strong base, which is the opposite of an acid. And when I poured in the cabbage juice, it did pretty much nothing because it is a very, very strong base. Okay, time for our next little thing. But first, I'm going to mix it up a little bit because this tends to, get a little separated when I leave it out for a little while. Mixing is just wonderful. Okay, so I've got my next stuff. I'm going to put in some more cabbage juice. Okay, we now have more cabbage juice. Now this, if you cannot see, is white, and it smells like mint. So we do not know what this is, once again. So I'm going to pour this in to see if it is. What happens? Interesting. So this looks like it is a stronger base. Now, if I mix this up, because this stuff does not really like to mix well, it turns into like a fairly deep blue. It's a little deeper than the water, which means it's a little bit stronger of a base. Whew. Strong mint stuff. Okay, next thing I'm going to mix up. I just have tons of stuff that doesn't like to stay together, just constantly. Okay, we have more mysterious liquid. Now I'm going to take this, put it in here, fill it with a tad bit more cabbage juice. Oh gosh, that is a lot of cabbage juice. If anybody has any other suggestions than cabbage juice, I'd be more than welcome in saying it. Just more than welcome. Oh, I forgot to say it, but the last thing that I just used, it was toothpaste. Toothpaste in water. This is already not mixed together again. It has separated once again. And I need to mix it up. I don't know why. This stuff doesn't, well, I do know why. It doesn't like each other. Does not like to stay together. Okay. So, I'm going to pour this in. In 3, 2, 1, go. Look at that color. It is, I'd say, aquamarine. It's about actually the same color as my background here. But I can't see it too well through this. But maybe through my shirt you can see it a little better. But it is a interesting blue color, which means, once again, it is a base. Now, this cabbage juice, man, I gotta come up with a better name. Cabbage juice is not, 100% great. And yes, that was baking soda in water. And baking soda is a strong base. Now, for our last thing, you guys just have to cover your ears and just close your eyes for literally 1 second. I'm just going to pull away from here for 1 second. Cover your ears. You heard nothing. You heard absolutely nothing. Okay? There was no sound of a soda opening at all whatsoever. Whoa, I'm back. And now we have stuff in the container. So I'm going to take this, acquire a bit more cabbage juice. Getting it all over my fingers. Okay. Now, as you can see, this is clear, and it has bubbles rising to the top. I wonder why. Mysterious liquid. No, it's not soda. Are you kidding? I mean, we don't know. So let's find out. Oh, look at that. It turned pink. I want to see the difference between this and the lemon juice. Lemon juice is basically the color red now. Yeah, it's basically the color red. There's almost zero difference, but this is a lemon soda. Or there are many competing brands, and I'm not sponsored, so I'm not going to say the name. careful between these soda companies. So this was a lemon soda, and it was an acid, so it turned this basically magenta color. Okay. So that was color change. Oh, wait. There's one more. I almost forgot. There's one last one. I don't know why it's so hard for me to get this cabbage juice. Okay. So, another random liquid. It is clear. And it smells sharp. I don't know how else to describe it. But I don't know what this liquid is. It's some crazy liquid. Okay, no, I don't like that smell. So let's see if we should consume this. Oh, look at that. It's another acid because it is once again bright red. Man, I'm getting all color shades of red. It looks cool. I kind of want to set it out like a line. So this is the strongest acid. And then this, anybody have any guesses what this is? It's sharp, and it was clear, and it is an acid. Those are your hints. It is vinegar. Correct. Good job, Rachel. Okay, so let's see. The darkest the blue is. So this is the scale. Acids to base. So this was lemon juice. This was vinegar. This was lemon soda, water, baking soda, and then toothpaste. Now, those are color change. Now I'm just going to move these out of the way for the next experiment. Oh, and so pretty much, so the reason why this happens is because the cabbage is and okay, let's see if I can explain this correctly. So the cabbage is red, right? Or almost a purple color. So when it mixes with either an acid or a base, it releases a special chemical, like I said, chemical reaction, and it changes color. But like for this, our bleach here, it is such a strong base, and I probably should be, if you ever do this experiment, make sure you're with an adult with supervision for doing this, because you don't want to get this on your skin. It does not feel good. Just gonna set that down. I'm treating it like a bomb. Okay, so okay, you know what? Oh, okay, so here's what I'm gonna say. I'm just getting a ton of stuff all at once. Okay, so pretty much the reason why I'm doing this camp right now, just in between experiments, the reason why I'm doing the camp is because, you know, COVID, not so great. Summer, really can't go to that many camps. It's kind of hard to do social distancing. And I got kind of bored, and I like science, so we're doing this. Okay, time for next experiment number 2. And remember, make sure to remember the, type in the chat which what kind of chemical change it is. Okay, so I'm going to leave this here. Now, this is milk. Just day-to-day milk. Now, I don't know if I've said this, but the 4 kinds of chemical changes is color change, temperature change, bubble formation, and then precipitation. And so, as you can see, color change, like from this before, like this stuff, it changes color from a color change. And so the next one we're gonna do, it's not temperature change. I'm not doing it in order, okay? So the next thing we're gonna do is we have milk and we have lemons. Tons and tons of lemons. So I'm gonna squeeze these in here. Now, it probably sounds really gross to have lemon juice in milk. I mean, I'm not gonna drink it. Ah! I just have incredible strength. You guys know that from the trial day when I tried to put on balloons. When I tried to put balloons on a funnel, that just worked out very well, as you guys may remember. Yes, it is lemon milk. Literally, lemon juice in milk. Now, as I have these two together, I don't know how clear it is if you can see, but so there's like a space in between where the lemon juice is on top and the milk is on the bottom. But in between, there's like little particles of milk inside of the lemon juice. Now, anybody know what kind of chemical change this is? It's either temperature change, precipitation, or bubbles. And it's still staying cold. Any guesses? It is precipitation. Good job, Kara. You got it correct. Okay, so that was kind of a short experiment, but all you really need is lemon juice, well, squeeze lemons in milk, and then you can see the precipitation for yourself. Ooh. I kind of want to smell it. Does it smell bad? It only smells like milk. Well, no, it smells like lemons. Oh, if this stream gets 7 likes, I'll try the lemon milk. Okay, I'm repeating that one more time. If this gets 7 likes, I will drink the lemon milk. The really disgusting looking lemon milk. I just want to wait for this to immediately get 7 likes and just, uh-oh. Okay, so next experiment. Materials. Plastic bag. Next materials. I really didn't have a thermometer, but I'm using one of the ones where you go. And it tells you temperature, 98.6, exactly how it should be. And then we got ourselves some lemons. Once again, more lemon stuff. I'm just telling you, if you ever want to be a scientist, have a constant supply of lemons. Just constantly. And our next ingredient, baking soda. Now, if you have seen the channel and have not subscribed yet, you will know that a main part of the channel is baking soda and vinegar. Just constantly. Man. Okay, well, oh, I can use my fork. Can I open it? Ah! So close. Aha! It has opened. There we go. My own way of opening it. Okay, so we now have the baking soda open, and we have lemons, juicer, and my own kind of thermometer. So, first thing we're gonna do is I'm just gonna measure the temperature of a plastic bag. 77.4 degrees Fahrenheit, which is pretty much the temperature inside my house. So, next thing I'm going to do open the Ziploc bag and juice the lemon inside of the bag. And the more juice, the better. Now, another thing you can use to, instead of lemon juice for this experiment, is pretty much any sort of acid works. Like anything that's really sour. That's like pretty much the best how it works. As you know, my strength is just insane. So I'm able to get, oh gosh, lots of lemon juice everywhere. Time for the second lemon. I'm gonna stick this in here. And also, when you cut the lemons, make sure you have parental supervision, because you don't want to cut yourself. Okay. And also, squeezing it in the bag is the best idea. Probably using almond milk, it probably will work. I actually have almond milk in my house. I might be able to do it with it. After this experiment, though. This one first. So, we now have the immense amount of lemon juice inside of the bag. Now, you can use, like, it doesn't really have to be a plastic bag, but I find it's best for times like this. So, we now have lemon juice in bag. So, I'm going to measure the lemon juice actually this time. Oh gosh. 75.8 degrees Fahrenheit. Now I'm going to add baking soda. Now, as you can see, chemical reaction happening. So I'm going to close this up. And we actually have two signs of chemical change happening right now. If you get two, you get double points. Okay, so now I'm going to measure the temperature of this. 62.0. Now, this isn't really meant for, measuring stuff like this, so it's not going to be 100% accurate, but it is colder, which means it is what kind of chemical change? Please tell me in the chat. And also, I'm pretty sure this also produces carbon dioxide because it is now full of air. And also, this kind of works as like a cold pack. Like if you're in a snag and you're hot, just cold pack. Feels good. Yeah, so pretty much that's how it works. Now it kind of looks strange. Now, this is the color I imagine lemon milk to look like. Kind of looks like I'm about to ice some cake. So, it is temperature change. Good job, Kara. Yeah, more people need to get in the chat. Kara's beating everybody. All right. And I'd say, I kind of want to see how long this works for. I haven't really left it in the bag. I'm going to wait, like, somebody in the chat, keep a timer for, like, 5 minutes, and I'm going to see if it's still, wait, let's measure it again and see what the temperature is. 68.2 degrees Fahrenheit. So I'm going to set this stuff here. And then I'm going to go get almond milk. Almond milk. Okay. Okay. we have almond milk. Wonderful almond milk. I guess I'm still not being sponsored, but I'm showing the name brand of this. Whew. Okay, so gonna take a bit more of this. This is the good stuff, almond milk. Gonna leave this over here. Now, I was not prepared for this, so I'm going to have to use some leftover lemons. I'm going to put multiple on top of each other like this. Well, that did the trick. I'd say it might actually be working a little better. That's actually really interesting. Thanks for the idea, Rachel. Oh man, only 1 like away from drinking lemon milk. 10 likes and I'll drink both almond and normal milk. This, once again, only smells like lemons. And yes, there is still the precipitation going on inside of here. So it does work with both of them. So it works. It works with both of them. Question answered. Okay. Don't want this stuff to fall over. I'm gonna put it on the table. Okay. Now we have big glass bowl. And we are going to use the staple ingredients of the channel. Vinegar. That was the thermometer. And baking soda. Okay, so if you are familiar with this kind of reaction, tell me in the chat what kind of reaction it is. Second, what kind of chemical change it is. Okay, so if you want to know how, like a pretty good ratio, I'd say you do probably a cup of this and a 1/4 cup of baking soda, and together it goes kablooey. Okay, so got our baking soda. Now, I don't really have a measurement for this, but I'm just going to stay right here. So we got our vinegar. We got our baking soda. Baking soda. Man, I'm just showing all sorts of brands today. Okay. No! Well, that is a reaction. I'd say I put about a 1/4 cup of baking soda in here. Maybe a little more than that. Hole's bigger than normal. So, does anybody know what kind of chemical reaction that was? I'm not drinking this one, I'm sorry. Okay. I have been given confirmation that there are 7 likes. Time to drink some lemon milk. It's probably just going to taste like lemons, probably because it's floating on top. That's not good. Okay. Holy mackerel. Off-camera sip of our non-sponsored soda. Jeez. That's a no-go. Don't want to do that. Like, really, don't. It's bad. That leaves a very, very nasty flavor in your mouth. Okay, so now we have all four of our chemical reactions. We have, first, we did color change. Then second, we did precipitation. Third, we did temperature change. And fourth, we did bubble formation. Now we're going to do one last experiment. A couple different times. Okay, it has been 5 minutes, I have been told. We are now going to see the temperature of our interesting experiment. It does not feel as cold. It feels about normal. 73.2 degrees. So it's gone up by 4.6 degrees, which means it does not work for long, and it kind of feels cold, but not really anymore. So I'd say it works about for 5 minutes. Okay. Behold, the beaker. So, I'm going to do another experiment, and you are going to type in the chat what kind of chemical change this is. Now, this is a wild card because we've already done all four. So, let me know in the chat. So, I'm going to do this experiment a couple different times. And so, the ingredients are hydrogen peroxide. Now, I got different kinds of hydrogen peroxide. These two have numbers on them, and my mom bought them at a local beauty store. Now, this one is expired. It has been for 3 years. So, we're going to use this one first. So, this is 3% hydrogen peroxide, 8%, 12%. So, what you're going to do is you're going to pour in a half cup of this, but not the stuff that has been not hydrogen peroxide for a while. You want to get, stuff that actually works. So, this is really slow. I'm going to undo the cap. And if you do not know, I have this little contraption set up because it causes a fairly large mess. So about here is about a half of a cup. Then, next thing we do, I'm going to dump out this lemon milk in my strange container full of a ton of different stuff. Yeah, I'm gonna wash this out real quick. I decided to grab a new cup. Okay, so we now have a new cup. Now, the reason why I have this new cup is because you are going to need some warm water and yeast. Now, for some reason, during COVID-19, it has been extremely hard to get yeast. I went to 3 separate stores and could not find it. So Amazon was the only solution. Why is it bread baking? Yeah, and everybody is using it for baking, as I have been told. So I've done this so many times that I kind of know how to eyeball it. So you want to use pretty hot, well, not hot, like warm water. Now this is kind of hot because it works a little bit better when it's a little warmer, as I have done through these experiments. Now the next thing, man, I got so much stuff on top of my yeast here. I have myself active yeast. Now active yeast works best because it happens almost immediately. And with about, I would say this is about 4 tablespoons of water. You want to use 1 tablespoon of active yeast. And yeast is the stuff that you use for like bread and cake. Is there 10 likes on this? Gotta be kidding me. Why are you guys, you're bullying me? I'm so sad I have to drink this disgusting almond milk. It looks like, oh my gosh. Now, this is safe to drink, but otherwise, don't, like, when you do experiments, don't drink it. Just don't, unless you ask your, like, science teacher or something like that. Don't drink it. Please don't. Bottoms up. That was horrible. Okay, that is a really weird texture. And especially because the almond milk is like vanilla flavored. It's, oh gosh. Oh my goodness, that's horrible looking. I don't know if you guys can see this through the top of here, but it's like, it looks really strange, and it's like become like a curd of like almond milk. No. It's bad. Also, thanks for 10 likes on the stream. Okay, so pretty much as I was saying before I was rudely interrupted by the amount of likes, this isn't thick enough. I think I put in a little bit too much water. You want to make it, the yeast water, to be fairly thick. Like, pretty, like, it can't be really, it's, you know, it's going to be watery because it's mainly water, but it can't be extremely watery because otherwise it really doesn't work through the experiment. Now we have our mixed up yeast water, and I'm using a chopstick to mix it up because it is the best utensil. Okay, so we now have our yeast water. Next, soap. So I'm going to take the soap, and you want to pour in, not like a super, like, don't run yourself out of soap. It's like a large squirt should be fine. So I now have our amazing bit of soap, and I've forgotten what this is called, hydrogen peroxide, in our beaker. So I'm going to pour the yeast water in the amount of, oh wait, I almost forgot. One thing you can do, food coloring in the yeast water. Now, I have discovered a couple drops does not suffice. You need it to be, because pretty much every single time you do it, it turns white. Almost every time. So I'm going to use blue for this experiment. So you want to put in, like, quite a large amount. Okay. So I have my quite large amount of in here, and this yeast water is like a yellowish color. So now I've got it in, it's like turning a turquoise. I might even need to put in a little bit more than this. Just a couple more drops. Because if not, it literally just becomes white. Like, that's it. we now have our colorful yeast water. Now, if it's like hot, don't don't touch it or anything like that. Okay, so let's put it in. Now, as you can see, my hands are messy. And I didn't even have to use the entire thing, but you probably can't see it, but it is steaming. Now, the reason for this is it's not because of the hot water. It's, because of the chemical reaction. Now, you can see a ton of stuff happening all at once. Oh gosh, this is just insane amounts of towels. Yes, I have summoning powers. That's how I got those towels here. Woo! Aha. Towels are just wonderful things. Now, anybody know what happened? What kind of chemical reactions I got? And it still continued to foam. So this, I probably could measure it, but I'd get soap all over it. But it is about, I'd say, it's over 100 degrees Fahrenheit. I know that. So like when you do it, if you touch it, it's like slime. It's wonderful. But it is hot. So, wait a little bit or like fan it before you touch it. And it was on my hand, it wasn't really that hot. But this is with the expired hydrogen peroxide. Just imagine what will happen with the new hydrogen peroxide. Okay, so anybody have any guesses on what kind of, man, there's a lot of soap coming out of here. It's basically a soap disaster. I just gave you guys a kind of a hint. I'm gonna wash this out. Okay, we now have our amazing washed out beaker. So once again, I'm going to do this experiment, but with the amazing hydrogen peroxide that is a stronger hydrogen peroxide. So it will work way better. So once again, I'm going to take hot water, and you can use the same cup because it's still, yeast and water. I'm going to put in a little less. I have like a yeast line from last time I did it. And I'm going to put another heaping spoonful of yeast inside. I'm going to mix it up. It actually doesn't smell that bad. Is that weird that I think yeast in water smells good? Okay. So that's mixed up good. More food coloring. Oh, there we go. Now I'm getting some good colors. Yeah, so you want to put in literally as much coloring as, as much as you want to. But like, I put in quite a bit, and it's not even blue. It's more of a green color because, yellow and blue makes green. Okay, so next thing I'm going to do, I'm going to start with the 20, and then last we're going to do 40. So I probably shouldn't have smelled that. Well, it doesn't really matter. So once again, eyeballing it. Oh yeah, and make sure not to get this on your hair. So I got this from like a beauty place. My mom did. And it's for bleaching your hair. So don't put it on your hair. Just do me a favor and don't put it on your hair. Okay, so we now have our yeast. Oh, missing soap. Whoa. Oh gosh, that was a little too much. That just kind of spilled over. Now, after a little while of doing the foam will start to go away. But not if my green yeast water has anything to say about it. Then I'm going to get a ton more foam. It does turn a color. Oh wait, hold on. Yay! Oh, the toothpaste. See, I don't know if you can see the steam coming from it. But I'm gonna let go of it because it is kind of hot. But there is absolutely steam coming from it. Okay. It is steaming like a ton. But as you can see, the more color that, well, not color. I guess the newer the hydrogen peroxide, the better it will work. Once again, I'm going to use my towels here. But does anybody have any idea what color it turned your hair? I mean, what color did it make the elephant toothpaste? Think about it. Even when I put in a ton of color. You know what I'm going to do, since this side has like almost nothing on it? And I'm going to take this thing. It's kind of leaking all over me now. I'm going to do this. Oh, it says high. It's too hot to even measure on this. Which probably means it's... What does even that mean? What is high? Well, it just says H-I though, not H-I-G-H. Is it saying hello? My thermometer is saying hi to you guys. Okay. So, I didn't really use much of that yeast. It kind of just happened. Okay, now it's getting everywhere. And for the last time I'm gonna do it, because it gets like the more concentrated it is, the hotter it gets. Assistant, if you could wash this, thank you. Now I have to clean my hands again. And I'm going to put on some gloves because I don't like my skin being very burnt. It's not, because that's not good, And I'd say wearing gloves is probably the best unless you're like allergic to latex, and use like latex-free gloves. Okay. Amazing flask once again. Okay, so we have used the 3, 8, but now the 12. So, once again, I'm going to pour in about a half cup of this stuff in there. I did a little extra. You know what? That's fine. Woo. Now, I'm not going to bother you guys with me mixing this up again forever. I'm just going to do a quick little one. Because I literally barely used any last time. Which kind of shows how far a little bit of yeast water can really go. Did that rhyme? I swear that rhymed. Once again, I'm blowing stuff up. Why do I have so much problems with like, wow. I have a lot of problems with like balloonish stuff. Okay. Okay, so just continuing to put these gloves on. I feel like I'm a surgeon. These are like so tight. Okay. I feel like that might make it work a little bit. I got the wrong fingers in the wrong places. I'm definitely a surgeon. Ah. Okay, pouring in some more soup. Whew. Okay. You know, I'm gonna try adding some food coloring in here too. And see what happens. Maybe the double food coloring will work. Okay. Okay, so now I've got yeast, this stuff, I forgot, why do I keep hydrogen peroxide and soap in there with double food coloring? Okay, let's see what happens. 3, 2, 1. It kind of worked. There's a lot more foam. I got it on the side of this cup too. It was green for literally 1 second. I wish there was a way I could show you guys all this steam coming up from here. But this is like an extremely cool experiment. And it's very awesome. It's like really hot though. Like really, like do not touch it. There's a lot of foam as I'm touching it. Okay. Well, it's not, yeah, so if you give it a little while, it's not that bad, but like immediately it really is steaming. Like, how can I explain this? It's like the amount of steam as if you were boiling water. It's like a lot of steam. Or like hot coffee or anything that's really, really hot. I wonder if the thermometer is just gonna say hi to you guys again. Or if it's gonna give me an actual temperature. I feel like this is hotter than last time. Error! So it's even worse. I guess if your thermometer says error, you probably should go to the hospital if it says, you know, error from your fever. Oh, I was about to blow inside of it again. I did that yesterday and it looked like I had a mustache. Amazing. What elephant toothpaste. Okay, so last chance to tell me what kind of chemical change happened. It's either A, color change, B, temperature change, C, bubbles formation, or B, precipitation, or E, all 4. I just threw in a wild card. I threw in a, why am I, this is like so much of this. I need to use my magic towels again. Just get this off of my hands. But this is like awesome though. Bubble formation is not correct. There is bubbles though. Well, I guess you could say it's part of the answer. You're a quarter of the way there. Okay, now I'm just gonna play with the foam. So you can see how wonderful this is. It's like shaving cream. And it feels really nice. It's like your hands are in a sauna. No, I did not break the glass. It's right here. Just fine. But it like, seriously, do this experiment. It's awesome. But with parental supervision, because this is, you know, really not an ideal temperature. It's like so much slime. Oh, now I'm like one of those really old science channels where they're just doing slime the entire time for every episode. Bubble slime, shaving cream slime, elephant toothpaste slime. Ah! Oh, this is so nice. So, now it is time for me to plug my own channel. So, thank you guys for coming to the very first day of the TheScienceKid camp. So, tomorrow I will be doing this again at the same exact time. So, I want to see you guys all here. And if you can give me, like, show me that you have been to all 3 of the classes, and on either post it on Instagram, Facebook, whatever, and tag me in it, and we will send you a certificate of surviving the first week of the TheScienceKid camp. And make sure to watch my other videos and subscribe to the channel. I'll make sure to see you guys next time. Tomorrow. And the day after that. And tomorrow we are going over the different kinds of energy. I kind of want to do like a Hadouken. Okay, so I'm just continuing to play with this amazing bow. All right. The next stream is at 11 a.m. tomorrow and on Thursday. Oh, I really like this stuff. Now all you guys are seeing is me playing with slime. All righty. Man, this is awesome stuff. And like tomorrow, if you tried any of the experiments, let me know. Because this is like, I don't know why, but this is like really nice. I feel like I keep on talking about how nice the phone is. Okay, you guys. See you guys next time. Bye-bye.